is this last part. So as you can see, we don't really have much. Now let us look at what can we do. Is it just that we should increase education? Well, unfortunately not. This is statistics from the United Nations. This is the number of students, this is Egypt here, the number of students enrolling in all different types of education in 20 years, from 1980 to 2005. So obviously we have been able to increase the number of students enrolling very significantly, which is quite good. But what is the impact of this enrolling on our GDP, our income? Almost nothing. Look at Singapore. This is Singapore. As they increase their education, their impact on their income is multiplying. This is because they focus on what they need to do. They focus on specific areas of science. Don't say we want to educate everyone and everything. No, we need engineers, so let's go ahead and do the best engineering programs. We need medical doctors, let's go out and do the best medical doctors. We're not interested in law, or we're not interested in pharmacology, for example. It doesn't matter what they choose, but they choose one area and they stick with it. They say, this is the area we need to work for the next 15 or 20 years. And as you can see, statistics do not lie. This is Singapore, this is Egypt. We have more students enrolled in all our different education systems than they have. But look at how their GDP has increased. Now, back again to the area of number of publications in the Middle East. This is looking more clearly or more focused on what is happening. Blue is Egypt, okay? And what we have here is that actually right next to Egypt is Iran. And what you can see is that as we go up to 2004, we were really the leaders. But I want you to look at 2003 and before that. Egypt was absolutely the leader. There was no one close to us, or even half of us. All right? At 2003, this is Iran. Remember, this green line is Iran. They started to increase very significantly. Now look at from 2004 to 2008. This is Iran, this is Egypt. Iran is the country number 25 worldwide in nanotechnology. They have more publications. They have almost 900 publications in 2008. Even more advanced than Israel in the number of their publications in nanotechnology. Now, what did they do in 2003 that resulted in this? They put a plan. They put what is called the National Nanotechnology Initiative, which is a plan to focus all their technology, all their funds in specific areas of research, specific areas in nanotechnology, and push forward and say this is where all our resources are going to go for the next 15 years. This is what happened. So what we need is a focus. Now what is happening in the Middle East? Saudi Arabia is putting over $6 billion in nanotechnology. United Arab Emirates, around $75 million, Bahrain, $100 million. Jordan, we don't know, but we know that they have a national nano initiative. Israel has put over $230 million in the past 3 years in civil applications and over $400 million in military applications of nanotechnology. Egypt, we don't have a national nano initiative, we don't have a specific plan for nanotechnology, but in the last year, in 2008, the amount of funds that has been put forward for different areas of research is $100 million, given by the Egyptian government, which is a very good step forward. Now, nanotechnology, back again. So we've talked about what is nanotechnology, what's the first applications of nanotechnology. We talked about different techniques, STM, atomic force microscopy, single molecule spectroscopy, and I have shown you how closely doing this type of research, which a lot of people would call fundamental research, have actually direct applications for the engineering, especially electric engineering. Then I've shown you the statistics that prove that developing countries can and have a chance to contribute to the body of nanotechnology, and it is really a way that can push us forward to catch the gap, because nanotechnology, as you've seen, is very new. There is a lot of fundamental knowledge that we do not know. We need a lot more research in these areas. Now, okay, so nanotechnology for the Middle East or for developing countries. What is it that makes nanotechnology such a good idea for developing countries? Well, there is a tremendous room for fundamental discovery. This is very important. There is a lot of fundamental knowledge that we do not know. If you go to silicon technology has been worked over for the past 100 years almost. Well, it's not 100 years, it's 60 or 70 years. But it has been researched to the bones. It's very difficult for a young nation or a nation that doesn't have this fundamental research to be able to compete. This is not the case in nanotechnology. The second thing is that current piece of technology, there is not much barriers to get this technology. There's no barriers to get the information and to start thinking, how can you use it? Well, it's low cost, but not low cost in terms of research. It's low cost in terms of application. The moment you actually find out the recipe that you need to use, implementing this recipe down to the factory and down to your lab is very simple and very cheap. The next thing is that it is global ideas, and you can take these global ideas and tailor it into local solutions. I'm going to show you some examples where an idea or a technology has been developed for something absolutely that has nothing to do with us as a developing country, but when you look at it, you can actually take the same technology as it is and apply it to developing countries, and it will make a big difference in our lives. It's an economic growth driver. As I've shown you, there are 64 national nano initiatives. 19 are coming from developing countries and 18 from developed countries. So, what are the areas of nanotechnology for the Middle East? We've looked into this, and these are, we call them the strategic area. Well, they're a strategic area for any country or any region. Okay? But let's look at them here. What we call them a strategic area because these require government funding. These have to be done, or the main driver is the government. There are other areas that I'm going to show you where the main driver should be the business, should be the industry, and should be the society. Agriculture and food, and I'm going to show you some examples in agriculture and food. Water, I'm going to show you one example in water. Energy, I'm going to show you one example in energy, or two examples. I don't remember how many I put in here. Healthcare, I'm not going to show you examples, but I'm going to tell you exactly what can be done in healthcare. So let's start by water. Water is a global problem, right? What you see here, this is called the life straw. This thing costs $3.5. It can provide clean water for a year for one individual. It kills bacteria, all different types of bacteria, 90% of different viruses, waterborne viruses. It removes all heavy metals, it removes all organic pollutions from the water. And it costs $3.5. It's built using carbon nanotubes inside of it. The company that produces this is only selling them for relief organizations, so the Red Cross, the Red Crescent, first responders. But there's other technologies that are similar, that are being sold on the market worldwide that use nanotechnology. The advantage of this is that you don't need electricity to get the water, you just have to draw that. Okay? It's a straw, like you're taking a juice. It takes water from any source, and we have tried it. It does clean the water. Okay? And it provides 700 liters of water per year, and it can last for a full year. So this is a solution for water problems in areas where you cannot have electricity, where it is very difficult to hook up these areas to electricity, and where it is very difficult to actually hook up a grid and build a water cleaning facility. Of course, there's other applications where you can put the same technology into a full functioning water cleaning system. So this is a simple example from water technology. The second area, agriculture. Now, one of the biggest problems we have in agriculture is that when you use pesticides, when you use chemicals to kill different pests in the plant, a lot of these chemicals are left in the plant that we end up eating. And when we eat them, they are a big problem. What can we do? Nanotechnology said, okay, instead of trying to change the type of the pesticide, we're going to put a shell around the pesticide. And this shell is only going to open up after certain conditions. Let's say an alkaline medium. All of us know that our stomach is actually acidic, which means if you eat this shell with the pesticide, it's not going to open. It's not going to release the chemical material in your stomach. It's only going to open when it is eaten by an alkaline stomach, which goes into an alkaline medium, which means it's only going to kill the insect or the pest that it is targeted to kill. These shells are 100% water soluble, and you can see them here on, this is a 10-week on concrete of